So yeah, hi folks, my name is Alexey. I work for Intel on SYCL compiler, and respectable hobbits have a second breakfast at this time, but we have a different journey. We will be talking about precious SYCL HPP. So let's start. We will talk about what is it, why is it a problem, how we're going to solve it, and some technical details and some summary. The problem statement is simple, that current design of SYCL HPP, that it includes the whole SYCL specification, it hurts compile time a lot. If you just take an empty file and compile it like with our Intel implementation for only device compilation and only syntax mode, so you don't build intermediate representation, don't do any IO or anything, just parsing and semantic checking, that could take seconds to finish on an empty file with just a single include, depending on your system. That's kind of a lot. And the problem is not unique to a single implementation, because we could do the following experiment. We could take non-standard bits std++ header, which basically includes the whole C++ standard library. And you probably don't use it, the whole of it, a lot. You just use certain parts. And we can compare it to SYCL HPP. So what I did, I took a system, I took a standard Clang, which was on the system, and compared those to headers. And we can see that all three implementations, like OneAPI, Adaptive CPP, and SymSYCL, this SYCL HPP header, it is way bigger than the whole standard C++ library, and you are paying that cost every time you compile SYCL application, however small your CPP file it is. Please note that this data does not represent an actual compile time, because I used random compiler, not an actual SYCL compiler for the corresponding implementation. For example, for OneAPI, this is roughly host compilation, but since we are multipass compiler, you may add up more passes for device and additional targets, so it's quite slow. You may ask a question, why is it so bad? Because I don't know, OpenCL or CUDA, they don't seem to have this huge problem. And some part of its design, we just put everything in one place. And also SYCL is C++, and C++ is somewhat heavy. For example, in Q, we have this prefetch method, and in many implementations, it just it's essentially a wrapper around Q submit and then common group handler prefetch. And simply for the compiler to make sure that this prefetch method is all the types are correct and everything, it has to instantiate this submit function, which accepts lambda the template. Then there is probably nested submits or whatever, and you have just paid the cost, even if you don't use this prefetch, you just paid it immediately. So how can we solve it? The solution here is to provide a separate set of finer-grained headers. We do not want to throw away SYCL HPP. We would like to preserve compatibility and still provide an easy way to jump and use SYCL, but still, for those who care, we would like to provide a separate set of headers for better control. For that, let's take a look what SYCL is. I looked at revision 9 and looked for all classes which are defined in the spec, ignoring enumerations. There's some stuff like half mock built-ins, which is not considered here, but this is a whole list of kind of features that SYCL spec provides. And how do we split all them? There are many questions how do we group them? What are the rules? Do we provide some core set which is usable for everyone, and how to define that set? If we are going to provide absolutely separate header for each feature, that could be an overkill. Some headers are not that heavy to be actually separated, and they use together very often. So there are also questions how strict we would like to be. Is it okay for implementation to actually not do a proper separation, not provide the best compile time performance, or not? There could be cases for some interdependencies, what if two features go together and that means that one automatically includes the other? I'm not saying that half and half is not solvable. That's probably an easy example which can be solved, but potentially there could be questions like this. So to kind of propose a split, what I did, I took a look at Hackbench at this commit, and there are roughly 660 benchmarks. And essentially for every feature, I counted number of benchmarks that use it. Like if we have kernel bundle class, how many benchmarks reference that kernel bundle class in their source code. And we have this picture. So queue, range, end range, handler, everywhere. But everything else, not so much. Vector is almost unused. I don't know, images do not exist. Kernel bundles as well. So yeah, not everything is being used, at least in this repo. If we get back to the list, this one is now sorted. So you can see that half of the list is like, haven't been mentioned at all. And even things which were mentioned, like, I don't know, only 10 items, which are bigger than 10%. So yeah, there is definitely room for improvement. So let's possibly propose one of them just to trigger a discussion, just to start with something. Top three, which are used like queue is everywhere. IDs, range, and the range, you work with this index space for every kernel, so that kind of also makes sense. And then we see that accessors aren't really used, or buffers aren't really used, so USM it is, we go with USM, and that's important header with all the related functionality. Then everything else, which still somewhat used, like buffers, accessors, classes like device, platform, context, or event, they're fairly small. There are not many templates in them, so they're all can be like bundled together. There is no issue with that. And like atomic ref, vectors, MRAs, built-ins will likely be split into separate, once again, headers, because there are so many groups of them and so many built-ins, you probably don't use them all in one application. And then the rest of it, because like who honestly cares probably for the most of it? You haven't seen that, I don't know, haven't used that stuff, but still, like, it would be nice to organize it somehow and provide access to it. And of course, we already have like the one and only. So let's take a look at an example of how it could look like. Once again, Hackbench, I took our bench SYCL from this commit. It's 400 lines of code. The code looks like we create a queue from, I believe, GPU selectors, and we allocate some memory. We submit a kernel which calls through some math functions, and we do some copies, and we free the memory. So a few features are used in there. And like we just compile it with regular SYCL with a single include. And if we were to change to like our new approach where headers are split, instead of one include, we would use 4. Here, I'm not exactly following the proposal I just presented simply because I did the experiments with whatever was available to me in our own implementation. And the split, like right now, today, would be somewhat the following. Queue will bring us queue, selectors, ranges, then USM stuff will go from separate header, built-ins, and some properties. So it doesn't like just 4 lines change, essentially. A diff is small. And that diff already gives a huge benefit, like roughly 40% compile time improvement just by changing 4 lines of code. And that, like, our headers are still pretty bad, like QHPV includes accessor and you don't use it, but you still pay for it. And even with that, you still get like 40% compile time improvement. There are also extensions besides like the core thing. And SYCL spec kind of solves that already. It allows for extension vendors, implementers, afters to like, it provides, so I don't know, namespace where to put their own headers, and essentially every author can create their own header for their own extensions, kind of not pollute SYCL.hpp. But it doesn't look like literally anyone is doing that. I was looking at many KHR proposals, I don't know, a couple of weeks ago. I don't think that any of them like actually uses this functionality. And we have dozens, literally dozens of extensions, like from one API Intel at our Intel VM repo. No one does it as well. So everything is being put into SYCL and everyone pays for everything, which is not exactly good. Couple of reasons of why it could be the case. I guess in general, people have not been considering compile time as an issue, maybe not thinking about that, not being aware. And sometimes with extensions, it is not exactly clear how to do that. For example, previously we heard about default context extension. And what it does, it adds a method into context class. How do you outline a method in a separate header, like unclear. So yeah, let's go also into some implementation details. Like you decide to move some stuff into, like, I don't know, split things, and I try to compile a list of like possible scenarios to see how user experience would look like. For example, if you split something, but then user made a mistake, forgot to include, would it look good or not? First of all, SYCL by itself is highly interconnected. So here, for example, you have Q. Q has some copy methods which accept accessors. Accessors have constructors which accept buffers. Accessors, I'm not sure exactly, I don't remember how exactly, but they also have methods which use handler, or buffer has get access, which also uses handler. Handler then has like use kernel bundle, and suddenly by using Q, you kind of included the whole SYCL. And if your implementer, like, I don't know, haven't been paying attention, they just lumped includes for every those classes everywhere, and you just get all of it. So solution is like, of course, we use forward declarations, but now we could do like, I think, two main things. The first one is we can move the actual definition to a separate header, so we don't need it immediately, or we could just move it into a library as a whole. Both can have pros and cons, because moving into a separate file could lead to worse user experience. Moving function to library is not always possible at all, and it also increases ABI surface for those implementers who would like to preserve backwards compatibility. It's one more symbol to take care of, makes your refactoring harder. If spec changes, you're also somewhat in trouble. So let's start. The first very simple case, you just have a method and you decide like, okay, with library, you can always move to the library and nothing really breaks. But because you have a declaration and a link time definition will be provided, but if you decide to move it into a separate header and users forgets to include that header, here you will get more or less nicer or message saying like, hey, context is incomplete, I can't do anything. And this is all because context is not a built-in type, but a user-defined type. That's important. So you can move to a separate header, you can move to library. User experience is more or less okay, diagnostic is there. It is not like as good as, I don't know, you forgot to include that, but still it will point you to something. A little bit more interesting use case is here, for example, buffer has this get access method, which is templated, and the whole buffer class is templated. And the problem with template parameter T is that it is user-defined. So you cannot quite move that into a library unless you do some type erasure techniques. It's possible, but requires some tricks. And if you just move definitions around headers and user forgets to include something, error is still somewhat like manageable, readable, understandable. Once again, you have something undefined you forget to include. It's not as cool as could be, but it's something. Once again, very important detail is that here the return type is a user-defined thing. Because if we had this, like we have a method which returns a built-in type, we could put into the library, no problem. But if you decide to move it in a separate header and user forgets to include that header, the error you will get, it won't be from compile time. It will be from linker, and it's also the worst, I don't know, because at best it tells you CPP file where something bad happens and you have this undefined reference. It's not quite clear that you forgot to include. Thankfully, this is a purely theoretical example. I haven't been able to find like an extension or core feature where such split between header would make sense, such implementation option would make sense, but still, just to be aware, don't do that if you're an implementer. And that one case is the worst. This is actually from our implementation. So in handler, you have this set specification constant method, and it is templated effectively on an address of a variable. So you can't move that into a library. And essentially, it's kind of a shortcut to get implicit kernel bundle and set spec constant to it. And in order to avoid including kernel bundle into handler FVP, we moved definition into kernel bundle. So you forget the include, and you get, once again, linker error, but this time the function name is mangled. So good luck understanding what does it mean and what do you do with it. So yeah, just be aware that moving stuff around and saying like spec this way could lead to such kinds of error, which are not always user-friendly. And essentially, that's kind of it. With current design of SYCL FPB, you pay for what you don't even use. That's not quite a C++ way or design of doing things. That's applicable to both core features and extensions that we have. This can be solved, and your feedback is most definitely welcome because everyone uses like SYCL differently. Different features are important and stuff. And I did my case study on, I don't know, one set of benchmarks, but it is not necessarily exactly representable for everyone. So there is already an issue in SYCL docs. You can go comment, give feedback, I don't know, ideas. Call to action to SYCL spec writers, especially those who work on extensions. It's probably a little bit premature to like actually provide separate headers because this split doesn't exist. So what do you do? Like, but still think about it. We would like to turn this into official extension and with the hope to maybe getting it into the core of whatever will be SYCL next version. And at that point, that will be your problem. You will need to think how to provide your extension for those who don't want to use SYCL HPP. You will kind of have to maintain two interfaces maybe. And to SYCL implementers. Compile time is important, especially like for early adoption, when you're just starting with SYCL. You're trying a simple example and it takes forever comparing to regular C++ to compile. That's, I don't know, doesn't give a good impression from SYCL in general, from the ecosystem. So take a look into it. Clang has time trace and various like instruments to look, introspect your code and see bottlenecks and improve. So yeah, that's it. Thanks.
Yeah, so thanks a lot for looking into this. I think it's really important. I have two questions. Sure. One is the old question, one is the new question. So the old question is, what do you think of precompiled headers and how they interact with this? And the new question is, what do you think of C++ 20 modules and how Windows interacts with that?
Okay. So internally, we have like feature requests to support both. We just haven't got around to any of that. It is somewhat, I think it is desirable to have both. Somewhat complicated in our implementation because it is two paths and like headers differ. We have the SYCL external macros. There could be device specialization plus multiple target specialization. That is definitely something we are aware of, that there is desire to support it. It's in our backlog, I would say. Maybe not the first priority for us right now, but we are aware of that feature. There is talk about SYCL runtime compilation tomorrow. And there it plays even more, I guess, important role, quick compile times, and maybe that will give us a boost to push through and finally support, I don't know, models or PCH. But yeah, we are aware that there is a desire to have that and we kind of share it. It would help, I think. Also improve like integration with the ecosystem, making SYCL closer to the C++, which is an end goal, I think. So, yeah.
Thank you.
I have a question.
Sure.
So I looked actually once into the same thing in an FTCP, and I also hit exactly the same difficulties as you with all of the interconnectedness and templates, making the whole thing very complicated, requiring huge amount of refactoring and also potentially putting constraints on the future development of the language because maybe you don't want to insert this template here, right?
Yeah.
And one idea that I had was that, well, maybe we cannot separate it that easily on such a fine-grained scale, but there are probably areas of the specification of the functionality where we can make cuts very easily. One obvious case is, for example, the host device boundary, right? You could have a SYCL device header, which then includes like the device built-ins and the VEC class and these kinds of things, and the host side, which would then include the context queue, whatnot, what you need to actually manage devices. And I think with this approach, maybe we can get an improvement with fairly little effort. Have you looked into something like this?
SYCL claims to be single source.
Yes.
So you have like everything in your single translation in the both device code and host code. So, I mean, you can probably hide some parts of the implementation, like if you have device only API, which is within kernel in host headers, you can hide its implementation, but the definition should still be there. And if you hide the implementation, it could somehow trip the host compiler. For example, we had cases where, I don't know, you have some group built-ins, it's called in your kernel, and on host, it just says unreachable. And therefore, when you compile your host part of the code, the whole kernel is essentially dead code because it's unreachable. Right. So something is thrown away. And we have some optimizations for static libraries and stuff, and therefore, like, it actually breaks us sometimes. So because all of your code, both device and host, in a single file, I'm not sure how exactly you could.
If you think about like runtime compilation, right? There, you're probably only going to be interested in the device code.
There, yes. There it could maybe help because you would use less APIs. Yeah. But for regular application, you still have all the APIs in your translation unit. So you
I agree as soon as you have kernel submission. But if maybe some parts of your application...
okay, like if you have like
device management,
host-only part, which only like, I don't know. Yeah, it could help, as well. There, like, as I said, there are different points of view how this split could be made because there are different use cases, different backgrounds, how you can approach it. And yeah, it requires some kind of discussion to like reach the agreement here because
it's difficult.
Yeah.
There's another question.
Here as well. One more here.
Just a thought that I had. Would it in theory also be possible to have like different ways to split the things? So you have like one set of headers that group the different classes in one way, then you have another set of headers that group them in another way, so you can pick in which way you want to divide the things depending on how you actually divide the different tasks in your own code.
Yeah. So C++, it provides some kind of split, but as you may know, like some features are available through multiple headers. And I think we'll probably end up with the same thing, like some APIs could be exposed through multiple headers, depending on what the main feature you use. You get like auxiliary feature as well for free, but through different code paths, headers.
Yeah, it's true that typically, I mean, in my case, I do have like quite a lot of headers that define like math utility stuff. And basically all they are using is vectors and math functions. And nothing else, and I still have to include like typically buffers, accessors, and whatnot because of that, and that does reflect quite a lot in CI time, and like just merging a pull request because of compile time, just because I have to include that giant cycle header is quite a problem in general.
It is also a problem for our testing as well.
But at least like could the split? I mean, typically like vector and generic like.
There are some things which are easier to outline because they don't have all the dependencies. Vector is self-contained, array is self-contained, most built-ins are like self-contained. There are some things which are easier to start with, for sure.
I was just thinking about like it's a trade-off between usability and compile time, right? All the time. So it's to use one header, to use the specific headers, and it will take a lot of time for you guys to figure out how to group it properly to decrease the compile time and agree on that on the spec level. Is it possible to create a tool which will just use AI maybe to understand, like if you write, it will be generic code, not just for SYCL, for C++ too. It just can give you a list of independent headers which you need to use instead of one. And that can be a really nice project, I believe.
Such tool exists for C++. I believe it's called include what you use. So yeah, it's not exactly new. But yeah, it exists.
Yeah, why not? Why not trying it?
I mean,
on existing workloads.
The problem with SYCL is that there is no even set of defined headers. So there is only one legal portable option, SYCL HPP. You don't have anything else technically. You don't have a guarantee that any of those headers which I showed like in detail that they exist at all. And we need to define them first, and then some tool can like actually use them.
But theoretically, we can train a model which will understand for each feature
I mean-
which set of
I mean,
headers you may use.
Yeah, yeah,
At least for specific implementation.
yeah.
So I was just curious, have you considered option to take a look on the CUDA implementation in order to learn something from them? Maybe it's beneficial to take a look how they solve it, because you mentioned that CUDA don't have this compilation issue.
Yeah, I haven't took a deep look, but from what I understand, like their API is C, so they don't have to play, they don't have this problem. And considering that it is C, they could also do some compiler tricks. Because, for example, in OpenCL, you don't have to use a header, and compiler can, on the fly, provide declarations for you, so it doesn't even have to parse the file. With C++ templates, it's slightly trickier. And for example, our implementation also puts everything into inline_v1 template for preserving KBI. So compiler doesn't even know like which actual templates it is. It's harder to do. So C++ nature kind of complicates things for us. But yeah, I should probably take maybe a deeper look to see, because I only did like very briefly.
Is it like C++ thing or template thing?
Also C++ thing, because you have namespaces and you can insert implicit namespaces, and that could, I don't know, compiler doesn't know which exact like path of namespace it need to forward declare it to, because every implementation can do some tricks internally.
Okay, thank you.
So it seemed to be will be a more political challenge than a technical one to savoir what we bundle together and all this kind of crap. I'm
Somewhat,
looking forward to that, but
somewhat, yes. Maybe.
the story of machine learning and at least giving people tools is like, at least to get us started, should we not, as a SYCL working group, just define a name of header, right? Like ndrange.hpp and stuff like that. At least doing that to get us started, right? At least just agreeing of a name for all the class, and we say, okay, the class should be on the name, or is this too much of a burden? At least then we may have some hope, because if it looked like doing from just SYCL.hpp to define whatever seemed a little challenging, and we had to just.
Yeah, I guess like we will just write a spec and say, hey, we propose that. And that already, I think it's a good start. We should start from exact proposal, because if it starts with talking, that will take forever. But if we have exact, like, say, we use this header with this name, it will contain that, and that it's a more, I don't know, objective discussion. And there are pros and cons, while like just theoretically think of what could be done, how could it be. Right? It is more indeed like, I don't know, agreements, less of a technical problem, more of like design language usability problem.
Yeah, I don't know if it's possible, but can we do like each class, it is in the name class.hpp, and we start with that, and it is systematic, and every time we have a class, we put a... Is this okay as an implementer?
We can, but I think that as a first step, we can do even better, but by already combining some of them, because it not always makes sense to absolutely every class in the separate header. So yeah, that's our baseline, but I think the first step would be even slightly better, because some of them we already know that they should be merged. There's no sense in like separating them. So yeah, we will start from stuffing close to like everything in separate header.
Okay, thank you.
And let's thank the speaker again.
Thank you.